In this video, we're going to study the conditions that would make estimates of prior year ultimates and also Solvency II risk measures consistent on updating. Every year you have another calendar year of data. How do we know that our estimates of SCR, Solvency Capital Requirement, market value margins, technical provisions, estimates of prior year ultimates are consistent? So let's look at and we're also going to be using real data for this. So let's look at a simple study where I've done a simple simulation. Let's suppose we create some data which has no process variability. It's essentially deterministic. And this data is based on this particular equation on a logarithmic scale. So let's suppose we have, let's suppose that W represents the accident year, D is the development year. So if you have a cell in accident year W and the corresponding development year is D, then the calendar year is actually, we start off with development year 0, the calendar year is W plus D minus 1. So over here we've got data that is deterministic. On the logarithmic scale there's a level of 10, there's a decay of 30%, and there's a calendar year trend say of 5%, which is constant. So this is deterministic data. And we also know that calendar year trends, the 5% projects on the accident year and the development year. So here are the numbers based on this deterministic equation. And let's suppose that we have complete runoff after 5 years or 6 years. So at development year 5, there's no more to pay thereafter. Okay, so that's what the numbers look like at the end of the year 2004. If the first accident year is 1999, the reserve, the ultimates, and then we take another calendar year, we go to the next calendar year, where the predictions, of course, are exactly the same as observations, it's deterministic, and so on. Now, what are the differences between our results or reserves and ultimates at the end of 2004 vis-a-vis year-end 2005? Well, you notice the ultimates are identical, 77, 77, 99, 99, but then we have another accident year. When we add another calendar year, we also add another accident year that we need to reserve for. We pay for the next calendar year, but we have to reserve for an additional accident year. You're not in runoff. You continue writing the business, say, with the same exposure. The ultimates vary from year to year on the log scale by 5%, so on the dollar scale, the effective increase is a little bit more than 5%. What happens to the total reserves? Well, let's see. The total reserves, let's work this out. At the end of 2004, the total reserves is the sum of the numbers in this triangle, in the cells in this triangle. Next year down, it's the sum of the numbers in the bottom triangle. But for every number in the top triangle, there's a number below it in the lower triangle, which is 5% higher. Therefore, the total reserves also increase by 5%. And in fact, it's only by projecting along that 5% trend line that the total reserves from year to year will go up by 5%, and you'll maintain consistent estimates of prior year ultimates. Okay? And these are not reserves, so each year the company needs to increase its total reserves by at least 5%. The ultimates of prior accident years will remain consistent with each increase in total reserves. Each year the company needs to increase its premium price by at least 5%. Ultimates increase by at least 5% from one accident year to the next. All right. So now let's look at the study. So I've got WCOM and WCOM1, and let's open each. WCOM1, if you just look at dimensions, let's see what's the difference in terms of dimensions. It's the same line of business, but we have an additional calendar year. So if we look at dimensions, you can see that for WCOM1, we have an additional diagonal, but also an additional accident year. All right, each one has a model. Let's scroll to the left, models. models. And let's run model good 1. And we'll do the same on the other side, good 1. And then we type vertically, minimize other types, so we're only looking at the model displays. And you can see basically the major difference is that the one that goes to 87, well, the trend stays consistent. In fact, the 87 data was actually simulated using the model for 81. In other words, the trend of 9.17% plus minus 1.57% played out at least for the next calendar year. And in fact, then the new trend, the estimate of the trend from 81 to 87 is statistically the same as the estimate of the trend from 81 to 86. Now let's do a forecast for each. 15 years, and let's estimate some other parameters. Estimate statistics conditional in the next calendar period. And this one, first one, we also have to make the same number of development years, and we estimate future parameters, estimates. And now let's look at the two forecasting tables. And you'll see that the total reserves, well, what's the trend? The trend's about 9.9. I think on a dollar scale it's about 11%. So you'll see the total reserves, 196 to 221, is around 11%. So the total has increased. Now, at the end of 1986, we're saying, let's look at these additional statistics. At the end of 1986, let's maximize this. At the end of 1986, our estimate of the mean ultimate is 64, and the standard deviation 5.8. Now, if you were to simulate the next calendar year and then calculate the new ultimate, and did that many times, simulate the next calendar year, put it in the expanded triangle, estimate the same model, estimate the ultimate. If you did this repeatedly many times, the mean of all these simulations of ultimates will be $64.9884 million. What will be the variation in mean ultimates? The variation will be about 4.322. So the standard deviation of the mean ultimates, if you did that simulation, will be about 4.3 million. The standard deviation now of 5.8, when you have another calendar year's worth of data, your forecasting horizon is shorter. The parameter uncertainty decreases because you've got more data. So that standard deviation of 5.8 will drop to 3.9. Now let's see actually what happened in one such simulation. When we now include the next calendar year, we find out that the estimate of the ultimate is actually 74. That's a pretty, sorry, it's 66. We're looking at the wrong year. So like 86 here, whoops, and 86 there. So if you have 69, over here it's 66. But you look at the kind of variation you'd expect in the mean, the standard deviation, at 3.75. So the 66 is really not too far away from the 69. Okay? It's not too far away from that. And you notice, therefore, the estimate of ultimates remain relatively consistent based on the standard deviation. So the ultimate here, 66 vis-a-vis 69, 71 vis-a-vis 84, we're looking, sorry, 85. 85 there, 85. Are we looking at the right years? No, we are looking at the wrong years. Actually, it was 64 versus 66. We looked at the wrong two. It's 64. The 64 has a standard deviation of 4.3, so the 64 is pretty close to the 66. In fact, what I could do here is do the forecast again so I don't get confused, and let's only go to 86. That'll be easier to look at. So now with the corresponding lines. So now we've got 66, 64, 71, 69, 62, 65, total of 529 with 516, but the standard deviation, the possible means, is 12, so the 529 is pretty close to the 516. Let's go back there, and also do a forecast including 87. Okay, so we have consistent estimates of prior year ultimates. And that is because our assumptions going forward are consistent. So anytime you have a model with a calendar year trend, you assume some future calendar year trend in the future, say in this case 9% plus minus something. If the next calendar year plays out to be around that trend, and when you estimate the new trend including that year, statistically it's the same as up to the previous year. When you do your forecasting, your estimates of prior year ultimates will be consistent, but so will also be your actual solvency capital metrics. So let's do the solvency capital metrics for each. Got to do lots of simulations. Now, of course, if you change your assumptions going forward, the answers will be very different. If you look at the standard techniques, if you look back at the study where we look at triangle group that we called ABC, where MAC doesn't capture the calendar year trends, every year you're going to get different answers, not because there's some kind of major instability in the data. The major instability is actually in the method. So you're going to get a distressed situation due to the model or method rather than what's going on actually in your business. You don't want your model, or you don't want to have a model error in distress. So let's compare now, just by the summary statistics, the SCR, why don't we do this, the 173 Bell compared to 195, is that about an extra 11%? Yeah, it is about an extra 11%. So the Bell, even though we used the discount rate, what was our settings? We used a risk-free rate of 4%, and we used a spread of 6%. Okay? That's what we did. Of course, you can vary these. So when you look at the metrics again, the metric summary, the Bells are consistent. The Bells are consistent. The VARs have not increased by a larger percentage than the mean, but just a small increase in the VAR. But you can see the SCRs are about the same. So because your assumptions in terms of forecasting consistent, the next year actually plays out according to your trend assumption, then you're going to get consistent estimates of solvency capital requirement. And that's the same story for the aggregate of multiple lines of business. But if the trend assumptions you're making in your method, and when using MAC and other kind of related methods, those assumptions are not even explicit. But if those assumptions going forward are not consistent from year to year, you're going to get very different answers each year. Here you don't. If you look at the solvency charts, compare that to that. Don't need this. You'll notice that when you're looking at the conditional Bells, MVMs, and VAR given the first year in distress, this is at the end of 87, vis-a-vis 88, you'll notice basically there's, in these graphs, there's about a 10% increase. It's just a 10% increase, which you'll kind of expect because of the 10% trend. But otherwise, all the statistics are pretty consistent. So let's look at the summary. Okay, if I went to WCOM1 and then decided, hold on a minute, I don't want to forecast with a trend of 10%. Let's use a different trend. Instead of making it 10% or 9 point something, why don't we make it 15? Let's make it 16. Well, of course, all the answers will be inconsistent. So if I compare the two forecast summaries, all the prior year ultimates will actually go up. So let's see now what happens. If you look at the ultimate for 86 at 79, and that's not very consistent with 86 of 64. If I make the trend much lower, then of course I'll get much lower answers. So the only way you're going to get consistent answers, do we have the SCR for that? We do. What about for that? We don't. Why don't we do the Solvency II calculations now? And then I'll get very different answers because our assumptions are inconsistent now. Remember, you can also use this for release of reserves if the conservative assumptions going forward you make doesn't actually play out. And you learn that exactly how much reserves to release. For instance, if you're going to be conservative, instead of assuming 11% for the next year, 15, and thereafter you go back to the 11, or sorry, the 9 point something percent, if the next year actually plays out 9%, but you made an assumption of 15, you know exactly what to release. So now if you compare the statistics, let's look at both, you'll see that, well now, your total at TP plus ESTA is 285, you need much more money. Your SCR has jumped from 27 million to 33 million, your VAR's gone up, your mean value has gone up from 173 million to 245, that's much higher, okay, because your assumption now is inconsistent. If we go to a project like ABC that we've dealt off before, if you use the MAC method on this project, you'll see that the MAC method always underfits the last 3 calendar years, so you always get answers that are too low. When the payments will come in, they'll be much larger than what you forecast, and then you'll say to yourself, wow, I must be in distress. No, it's because the model is in distress. If you go back to our videos, we do actually study ABC, this particular project. It's called, the triangle group is called ABC. So you need to be very careful about the models giving you accurate reflections of what's going on in the business, and also be very careful about what assumptions you're making going forward. With these standard techniques, MAC and related methods and all the other derivatives, you don't know what assumptions you're making going forward. Okay, thank you for that.